Hello, guys. Good evening to one and all. I hope you all are doing good today. So, today we are continuing with the part two of our Python interview series. And I hope the previous series was very helpful to you and the content was very technically sound. So, continuing with the very good response for the previous video, we are continuing to the second part. And I hope this video gives you a lot of knowledge required for you to attend the interviews and ace a good job. So, you all know the routine before we jump into the content. Grab a coffee, come sit, feel relaxed, and stay focused for an hour. If you have any doubt, do drop your questions in the comment section and then make sure that you practice all these. Even when we finish the video, if you don't get any questions right, just drop the question again. I might try to address that in the next interview series parts. So, who are we? We are Data Valley, the fastest growing edtech company of 2025. And myself, I'm Franklin. I have almost 3+ years as a data engineer. So herein I've got you all the stuff that is required for you to ace your interviews. And these are entirely based on demand and real world scenario questions. And personally, these questions were asked to me and to my friends in my network as well. So this is not just from some random dump, but rather it is like all content oriented and it is all realistically asked questions. So please pay attention and make sure that you learn as much as possible. So, not wasting your time, let's jump to the video for today. So today we are starting with our interview series part 2. So to start with, the first question I would like to address is, what is a data pipeline? So here is a definition. Then I might try to put in easy words for you to understand it better. A data pipeline is a series of automated steps that move and process data from one or more sources to a destination where it can be analyzed and used. It's essentially a pathway for data, ensuring it's transformed, cleaned, and delivered in a usable format for various purposes like business intelligence, machine learning, or data warehousing. In short, what I'm trying to tell is that what is a pipeline basically? Pipeline is something that you use to transfer something in between two sources and a target, right? So pipeline is a connection that you establish between a source and a target so that you can move something out of those pipeline, right? Similarly, talking about data pipeline, so you're going to have the same concept. You'll have a source and you're going to have a target. Between this source and the target, you're establishing a system where your data gets transferred. So there are few things that will happen during the transfer, which we call as transformation. But leaving that, I hope you all understood what a data pipeline is. It is a process or a system that you establish to move and process your data. So let's talk about the core components. So talking about the core components, you have a source. So source can be anything. It can be a database, it can be an API source, it can be an application, or it can be even an IoT device. But a data pipeline begins with this source as an origin. Okay? From this, then what happens in intermediate is that this involves transforming the raw data into usable format. Any data must be transformed into an information. Not all data is an information, basically. So you need you need to convert those raw data into useful format, or in other words, and useful information so that it benefits your business, right? So this processing phase involves transforming this raw data into useful format, and to do that, it'll involve steps like cleaning the data, filtering the data, aggregating, and reformatting data. So cleaning might include like handling your null values. Filtering might include like removing the unwanted data or columns. Aggregating might say that how you're trying to group your data, on what basis are you trying to partition it and bucket it for the better performance. Reformatting data might say that, like, for example, you need a date format in a particular way that you use locally, so you convert the date format. For instance, let's say in a different country they write as year, month, and date, but locally you're trying to use date, month, and year. So that's how you do the transformation. So that's what I mean by reformatting. So, and then the third component within data pipeline is a destination. The destination can be same as I said previously. It can be another application, it can be another database, or a data warehouse in most common cases. So this is the final stage where the data that has been processed will be stored. Okay, so it will be stored to a destination. So these are the core components of a data pipeline. And you have different types of data pipeline as well. We have discussed this plenty of times, but it doesn't matter. I want you all to be very good and thorough about it. So two types of data pipeline are batch pipelines and streaming pipelines. So in batch pipelines, you process the data in chunks, or you process the data in batches. So batch pipelines is especially used when you're trying to analyze some historical data, or you're trying to report some previously stored information. So that's when you do a batch processing. So you can consider a batch like you have data from yesterday to today, and you're processing it tonight. So it's a batch of data from yesterday 12 to today's 12. So a period of 24 hours of data you have it, and you then process it as a chunk. Okay, so that's what is a batch pipeline about. Talking about streaming pipeline, so streaming pipeline is where you construct a pipeline that processes the data in real time, and the data is made available immediately. So therefore it helps in immediate insights, and the reporters or the machine learning team or business intelligence team can try to take some action out of the live data that is being produced. For example, let's say you're trying to work for a trading company. The trading companies need the data immediately, right? They need to know the market cap immediately. They need to know what's the price of the, let's say, a stock or a crypto. They need to know the data immediately. So what happens, the data must be processed immediately. For example, let's say you are a gamer, you play a game, right? So these games, when you play, and let's say you're setting a new record, let's say you've broken a record and you've become the number one highest scorer. So how does it get updated into the web system? So how does the database internally gets to know it, and it sends a report to every player? So that's how it is done. So once you finish your game, the real-time data is taken out or pulled from your source, and then it is processed as required, and then it is stored, or it is sent to the target destination from where we get the real-time analytics. All right, so that's where you use streaming pipelines. So here are the key functions that are part of the data pipeline. So it includes data integration. So as we discussed, we have a source. From there, you bring together the data from multiple sources into a unified view. And then you have a transformation phase where you convert the data into consistent and useful format. And then while transforming, then you also ensure about the data quality. So you ensure for accuracy, you ensure completeness, reliability of the data. So you try to enrich the data as much as possible. And then data pipelines also involve automation. So it includes automating a data flow and processing steps to improve efficiency and reduce manual effort. So what I'm trying to tell is that you can construct a pipeline, and it is okay if you're running it frequently for testing purpose. But when it comes to production, you cannot always rely manually on one of the team member. Okay, you need to make sure that all these processes, the integration, the extraction, the transformation, the loading, ensuring data quality, all these must be automated. So automation is part of data pipeline where these processing steps and data flow happens frequently without any intervention of manual effort. So therefore you can avoid any kind of human errors as much as possible, at least. So these are the key functions of a data pipeline. So jumping to our next question, we already saw about what is batch and stream, but let's see, it doesn't matter, it's always good to learn in a different aspect. So talking about batch processing, so in batch processing, the approach is that you collect and store the data over time, then process it in a large groups or batches at scheduled interval. So as I said previously, let's say I'm running a store. Okay, my shop opens at 7 in the morning and it closes at 11 in the night. So I'm going to have at least few thousands of transactions happening per day. So instead of processing it immediately, I can ensure that I open the day, the first transaction happens at 7, the last transaction ends at around 11. So I can set a batch processing that can run exactly at 12 in the night. So all these collected transactions will be processed at once. So that is what you call as a batch processing. So you're processing it as a complete batch or a group, right? So that's the approach for batch processing. So talking about latency, you get high latency because there's a delay between the data collection and processing, right? So your data is going to be typically available after a few hours if you're processing it based on hourly basis, or you're going to have it typically after a day if you're processing it after 24 hours. So the latency is high, and you get to see only the stale data, not the real time. So that's why you get high latency. And the data volume is really huge because you're processing it as a batch. So the transaction is going to pile up for each minute or each second depending on your store. So the more the data piles up, the volume is going to get higher. So you have to handle large volumes of data efficiently. Then the complexity is, it is less complex in comparison to real-time processing, as you have time and to understand your data. So, and when you are performing the processing in offline, you don't really have to worry about the complexity, because even if there is some worst thing that could happen, you still have time to sort it out and make sure that your data pipeline runs smoothly. Talking about the use case, it is very good for use cases like data warehousing, for a data mining, data analytics, or let's say you want to generate some report, or you're trying to understand or create an historical analysis. Then the use case is perfect and you can go for batch processing, and you're okay with the stale data and no immediate action or any real-time analysis is not required. So talking about the infrastructure and cost, it's less complex infrastructure, and it often leverages the existing storage and computing resources without requiring continuous operations, potentially leading to lower cost. So you already have your infrastructure set up, so you already have your job set up, so you use cron jobs to run your pipeline on a periodic basis. So that's when your compute resources get activated or resumed, and then you use those infrastructure to process your data. So it's bit lesser complex in comparison to real-time processing. So few examples where you use batch processing includes payroll, your billing, the inventory management, and generating end of day financial reports. So these are the few examples where batch processing is availed. Talking about streaming data processing, the approach here is that We process the data continuously as it arrives and making sure that we analyze the data in real time. So this is the approach in difference to the batch processing. All right. Then talking about latency, we had high latency for batch processing. And talking about streaming, you have low latency because the results will be available immediately within milliseconds or seconds. The best example that I gave already was, let's say, your trading account. Let's say you're working for a stock company. Let's say you're running a financial website. You need the data available immediately, right? Because the stock prices or the crypto price, whatever you're working on in real time, the price might change immediately per second or per millisecond, right? It is going to have an impact. Let's say you have some thousand stocks, and even if the price varies by like few pennies, the price range is going to differ a lot, right? So while if you're working for a trading company, you have to ensure that you need a low latency of data so that you can make sure that the business use case is met. And talking about the volume, because we process the data in batches for the batch processing, your data is going to be huge. But in streaming, you're going to handle the data continuously. You might have high velocity of data but not high volume of data, right? So what do I mean by high volume and high velocity? So volume is that the amount of data, and velocity means at what rate does the data come in. So you might have high velocity. What do I mean by that? You might have more number of transactions happening simultaneously, but those transactions still carry a low volume of data. So you are designing to handle a high velocity but low volume data stream. Talking about complexity, it is more complex in comparison to batch processing because you're not performing any offline operations, but rather an immediate real time action, right? So you need to manage your continuous data flows. You need to implement fault tolerance. You need to maintain the state. And you also have to do dynamic scaling. What do I mean by dynamic scaling? Let's say you have 1,000 customers making their transactions immediately. So you need to ensure that your systems could handle it. You have to ensure that your pipeline could take 1,000 transactions at a go at once. So that's what I mean by dynamic scaling. And fault tolerance is that just because you had 1,000 transaction doesn't mean that your pipeline must crash. So your system must be fault tolerant enough to handle all these simultaneous transactions. So it is a bit more complex in comparison to batch processing. And use cases is when you need real-time insights and immediate requirement for your streaming data action is required. So for example, let's say you're trying to detect a fraud. So you will be performing fraud analytics. So you need to ensure that your data is available immediately. Let's say you're doing live dashboards. So your gaming platform is the best example. So you're going to have a dashboard where you're going to see different players and their scores live at the moment, right? So you need to have it for live dashboards while you're monitoring the systems and for IoT data analysis. So data must be processed at a go, and it must be stored or processed for further analysis immediately. And infrastructure and cost, it requires specialized infrastructure and high performance computing resources to handle continuous data flows, potentially incurring higher cost. For batch processing, you know that what is the quantity of data you're going to handle, and you're not going to handle any bandwidth problem or not real-time streaming problems. But in case of a streaming, you have to ensure that all these are handled well and balanced. So this requires specialized infrastructure, ensuring that you have high performance, and you also have to ensure that your computing resources are able to scale and they are fault tolerant enough to handle continuous data flow, because you don't want to lose on your data, right? So a few examples include real-time analytics for financial transactions. Let's say you're withdrawing some money from your bank. and you need to get an immediate message saying that you have withdrawn so and so money, and your balance is this much. So you're going to have some real time insight on your transaction. So you need streaming data processing for that. You will be using it for IoT sensor data processing. Let's say you're working for a baking company. All right, so you're going to have the IoT sensors that is going to ensure that the heat being applied on these cakes are at the right temperature. And when they exceed, you need real time sensor data that will be used for further, you know, further process. It could be for different analysis, right? So you have to ensure about it. So another use case is you have to monitor your user activity on websites. Let's say you're working for a retail company, and they have third party companies. Like, let's say I have a product, I have my own company. Let's say my product name is whatever you want to call, let's say Firefox. Okay, Firefox is my product. And then I'm also selling it in different third party websites like Amazon, Flipkart, Misho. So different websites, right? You have eBay, Facebook Marketplace. And let's say I need to monitor the activity. So how do I do that? So I need streaming data to monitor my users activity in different third party website as well as mine. So you can also use it for personalized recommendations, right? So when you just put in some data into Instagram, and then you're going to have frequent recommendations about particular product, right? Let's say in Netflix, you're going to have movie recommendation immediately. In Instagram, you're going to have content recommendation. For products like in different sites like Amazon or Flipkart, eBay, you're going to have product recommendation, right? So you use streaming data processing in context to that as well. So this is a key thing for your business. So choosing the right approach. The best approach depends on your specific needs. So data characteristics, latency requirements, budget, and existing technology stack. So what do I mean by that? Specific need means that what is your business use case? Do you really need to process the data immediately, or are you okay to process your data after a period or after a certain period of time? So it depends on your business use case and what is the goal of your business. And then what is the characteristics of your data? So talking about the characteristics of a data, it could be like, is that a financial data? Is that a retail information data? Is that like a web activity data? So these kinds of data possess different characteristics to them. So it depends on it. And then latency requirement. So talking about latency, if you're okay with high latency, go for batch. If you need real time fast latency, then you have to go for streaming. Talking about budget, batch is budget friendly, and streaming is bit costlier because you have a lot of infrastructure, and you have to make sure that you have a fault tolerant architecture to handle all your transactions or your high volume of data, high velocity of data. So the budget is a bit higher for real time streaming. And you also have to consider what is your existing technology stack. So depending on that, you can come to a conclusion that what kind of processing do we need for the business. So a short note here, a batch processing is good choice if you're having large volumes of historical data and where you don't need immediate analysis. If you have budget constraint, go for batch processing, and also try to use the existing infrastructure which can handle higher volume of data but not high velocity of data. And streaming processing is better if you require real-time insights and you need immediate action. Okay, and you also have a continuous high velocity data stream, so then go for stream processing. So our next question, how do you handle missing data in pandas? We will cover pandas in a different full series starting from the basic, but because this is a Python interview series and these questions are a bit common in case if you're a data engineer or data analyst kind of roles. So just remember the syntax. The main point is remember the syntax. Okay, so you have two options to handle your missing data. The first one is drop NA. So in normal words, what do you call NA as? It's non-applicable, right? It's not applicable data. So similarly, the data is not applicable. It is a null, right? Sorry, it's a missing data. So what do you do? So you drop it. So df. So df is your data frame. It can be anything. It can be any data frame. For example, let's say I have a data frame called customer. So it's a just a alias name for my data frame with the dot notation. Then I suggest that remove the rows with the missing values. So the syntax is dot drop na, okay, with the brackets, open and close bracket at the end. Let's say I want to not to remove the missing values, but rather I want to fill it with some useful data that can be beneficial for my business use case. Then all you got to do is you got to fill it. So again, the customer data frame alias name. So let's say it's my customer df, and then it's a dot notation again, and then I'm using the function fill na. So you're going to fill the na, right? Simple, just remember it that way. So it's a not it's a missing data. So na is missing data. So you're going to fill it with some value, and within the bracket you have to mention what kind of data are you going to fill it. So if it is an integer, you can just put it as 0, or if it is any kind of categorical value, then you have to put maybe not defined. So this is how you fill your missing data in pandas. All right. So our next question: what is Airflow and why is it used? So Apache Airflow is a very common open source platform used by the data engineers. Okay. So by definition, Apache Airflow is an open source platform used to programmatically author, schedule, and monitor workflows. So what do I mean by Apache Airflow is that it is an workflow orchestration tool. What do I mean by workflow orchestration? So orchestrating is something where you run something in a periodical way, or orchestration is something where you have a set of activity running in an organized way, right? So that's what you call as orchestration. So workflow orchestration. So what do I mean by workflow? Workflow is where you have series of data pipeline or series of pipelines that requires ETL jobs to be performed. So what do you do? So you use Apache Airflow, and then you programmatically set the workflow orchestration, or you set a periodic, or you set a scheduled work so that your job runs periodically. It's primarily used for orchestrating complex data pipelines as discussed, and it involves sequencing, coordinating, managing the flow of data from various sources. So you get to define how your data flows. So you might have a different sources, you might have different targets. So all these needs to be processed in line, right? So all these need to be processed in a flow. So you don't want to have a system where your workflows run in an unsystematic way, right? So you're working as a data engineer, and you need to ensure that your data flow is running in a proper scheduled way. So you're managing all this workflow, and you're ensuring that these workflow run in a sequenced, coordinated, and in an organized way. So Airflow's core principle is that we define workflow as code, and Python is a language we typically use for workflow orchestration. Okay. And Airflow also enables dynamic and scalable data pipelines. We will discuss about it later, about what do I mean by dynamic and scalable. Or maybe I'll let you know in a short. So you're going to have data pipeline, and that might need a scalability, right? For instance, I just previously said about streaming and batch transactions. So talking about real-time streaming, there might be an instance where you're going to have thousands customers making a simultaneous transaction. So you're going to have 1,000 transactions at once. and your system must be able to handle them, right? So airflow also helps with your dynamic and scalable data pipelines. So how do airflow work? It uses DAX. So what do I mean by DAX? So DAX mean directed acyclic graph. We will discuss about DAX in a further question, but just know that it uses DAX to orchestrate your workflow. So DAX have two components, the nodes, and then you have edges. Okay, so nodes define your task and edges define the dependency required for the task to be running. So also airflow uses extensible operators that allows us to run tasks of different types. Okay, so different types, what do I mean by that? You can have spark operator, bash operator, you can have SQL operators. So these are different operators that you will be using to run your task. And so our next question, what is a DAG? So this is where you're going to see it in a very detailed way. So as I said earlier, DAG stands for Directed Acyclic Graph. So you just get to see a picture here, right? So from A, it is working towards B, C, and E. From B, it is directed towards D, and from C, it is directed to D. So from A, you get to flow towards B, D, C, and E. From B, you are defining it to D. From C, you are defining it to D again, and from D, it is directed against towards E. So try to get a idea about this picture first before I explain what is a DAG. So DAG is a directed acyclic graph, as I said earlier. So you are going to have a visual representation of the data pipeline or workflow. Okay. So as I said earlier, why do you use Airflow? To orchestrate your workflow. All right. Same way. So they use DAX. So DAX, what do they do? So they orchestrate your workflow. Okay. And these visual representations, okay, of your workflow represent a node. So node is this circle, right? A, B, C, D, and E. Those are the nodes. And then you have edges. So these are the edges. Okay, the arrow marks that you see there, these are the edges. And edges are the dependency that are required for these tasks or the nodes to perform. Okay. And also these DAGs represent the outline in which order the task must be executed. Okay, also ensuring that the dependencies are met before any task is further initiated. DAGs are crucial for managing complex data workflows, especially in tools like Apache Airflow, where they define the structure and execution flow of data processing tasks. So as I said earlier, just remember this, okay? In short, Airflow is a workflow orchestration tool and they use DAGs. So DAGs represent directed acyclic graph. So directed is they are going to have a direction. So it is not going to loop or it is not going to have a cyclic format, but rather it is a graph that is directed. Okay, it is going to follow a direction. And what do I mean by acyclic is that the operation is never going to loop. Okay, it is not going to be like A depends on B and B depends on A. So it's directed from A to B, B to D, right? So this is directed in such a way that it doesn't cycle back to its further dependency. So this is how nodes and edges come into play within Airflow DAX. This is a bit crucial. Try to understand this. So nodes represent tasks, as I said earlier, and edges represent your dependency. Okay. So the more the node, it represents that there is more tasks to be performed. And these tasks are different units of work. Okay. So in our case, we had A, B, C, D, E, right? These are the nodes, and each nodes define a different unit of work. And they are part of a workflow, and each work could be executing a different work. Like one could use a Python function, the other could use to run a bash command, the other could run some other kind of scripting language, and then it also interacts with your external system. Whereas edges are the connections between two different nodes. Okay, so for example, in our case, we have multiple edges from A to B, A to D, A to C, and A to E. So you're seeing the arrow marks, those are the dependencies, okay, or the edges, and these carry the dependency in which the order the task must be executed. In our simple use case, the edge pointing from A to B signifies that task A must complete successfully before task B can begin. Here, the dependencies ensure that if I'm running from task A to B, okay, the node A to B, okay, or the task A to B. So before running B, the dependencies ensure that the task A is complete. So then it moves to B. And before initiating the task D, task B is ensured that it is complete. So the dependency will ensure that B is completed before initiating the task D. All right. So to our next question, how do you interact with RESTful APIs in Python? So especially in the domain of data engineering, we always handle this RESTful APIs. Okay. To interact with this REST APIs, we use a primarily used Python library called HTTP requests. Okay, so to make a request to these APIs, we use a library called requests. Okay, so interacting with REST APIs in Python, so you're going to interact with your REST APIs. So it involves you making an HTTP request. Okay, so you're going to make a request to the REST API, and then you process the responses. So that is how you interact with your REST APIs. And to make a request to this REST API, so as the name suggests, you have a library called requests. Okay, so you have a library called requests within Python, with which you interact with the REST APIs, which then is further processed based on the responses. So how do you import it? So first you have to install the library, right? So I'll show you the code. So because I'm running in Collab, I'm using the exclamation mark at the front. So I'm installing requests. So pip install requests, and then once I install it, I have to import the request library as well. Okay. So request library provides us with various HTTP methods with which you get to interact with your data that is being fetched from this APIs. Okay. For example, in here, I have a web link here. Okay. The API link or the REST API here. So I'm using request library. So I'm creating a variable called, okay, let's forget about it. So what I'm doing? So request is my library. And then I'm using a function called get, or you can call it get method. So this get method is going to help you with retrieving your data. Okay, I'm passing it into a variable so that I can further use it in my code. So request dot get, and then the REST API link. So once I get it, then I'm passing it into another variable called data to fetch it. Okay, so response dot JSON, because I'm getting the data in the JSON format, I'm passing it in a JSON function, and then I'm printing it. Let's see how our data is getting printed. Okay, so it has fetched the data, and you can see that we have printed it. So ID is 1, name is Google Pixel 6 Pro, and the data for that is color, which is cloudy white, capacity, and then for ID2 you have a phone called Apple iPhone 12 mini, and then you're having further data about it. So you're seeing a different data for each ID. So this is how you fetch the data. Okay, so you retrieve the data from a source using a function called get method within requests. And then you have post. So post is when you need to send the data to create a new resource. Okay, So get is where you fetch your data or retrieve your data from the source, and post is where you send the data to create a new resource. So how do I do that? Make sure that you have imported your request library. Then I'm using a variable, okay? I'm using a variable called payload. Then within a dictionary, I'm putting a key and a value, okay? So key, for example, let's say I have a JSON. So key is going to be, for example, in the above case, I'm going to have something like ID, okay? So ID, then the value. So it could be ID, any ID and that I would like to input, for example, 2. So then what I'm trying to do, I'm using response, another variable, so you don't have to memorize this words like payload and response. So payload is the data I want to send it, and then I'm using request dot post. So post is a method that you use to send the data. So this is my API. To this API, then I'm telling you have to upload this data, so make these changes, okay, and create a new data for this, okay. So that's how you use post function within request library. And then you have put and patch. So this is when you need to update your existing resource, okay. You use post to create a new resource, and you use put to update the existing resource. Similarly, ensure that you have imported the request library. Then you are having the payload information, okay. So when you try to add in or create a new resource, you created a key and a value, right? So similarly, I'm creating a new value here as new key and a new value, and using the same variable response, I'm using request.put, which is going to update my existing resource. I'm passing the API link, and then I'm saying it is JSON is equal to payload, okay. And in case if it is a patch, you just have to replace the word put. And then let's say I need to remove my resource, then you just have to use dot delete method with the request library, okay. Similarly, you have to import, make sure you have imported the library, and then you're passing it into a variable called response, and the syntax is request dot delete method with the API link. So with this link, I'm saying that okay, delete those resources. So that's why I use a delete method within the request library. And there are a few ways how you handle responses. So once you make a request, the response object contains information about the server's reply. So whatever the response object, so we created in here response objects, right? So we have a response variable, so which is an object that contains information about the server's reply. So different status codes means that it is giving a different response. So we have to ensure that this response dot status code is checked, okay. So it will ensure that if the request was successful, was the connection established, and the changes have been done. So for example, you get status code 200 to ensure that your response is okay. And for the response content, you can access the response body as text with response.text, or as JSON if applicable with response.json function. So we already used response.json function here, right? So we pass the response, so it is having some data within it. So for that data, then I'm passing it into a data variable or a data object. Then I'm using response.json to get my data or to view the content of my response. Then I have headers. So headers helps us to access the response headers, okay. So that is the main functionality of using headers. So I do have an example code here for you to understand better. I'm importing the library request, then I'm having an API URL, okay. So the URL, I'm passing it as an argument, and then I'm using a response object. So request.get API URL, okay. I'm going to fetch the information, right? Request.get is going to get the data from the particular URL. So instead of passing it directly, I'm passing it using an argument. Then I'm letting know the system that If response dot status code is equal to 200, then so what is 200? 200 means the response is okay. Then I am passing a data object and I'm telling okay response dot JSON, which means that I need to see the content of the body. Okay, then I'm printing successfully retrieved data, and then I'm printing the object as well, the data object which has the data from the response. Then I'm telling okay else, okay, if there is a different response, if the response is not okay, then print the error along with the code and what the information is. So let's say if I'm running this, then I'm finding the print statement saying that okay, the job has been successfully done and hence you have retrieved the data, and the data for that API link is that user ID is 1, title is delectus, autumn, and it is completed false. So these are the data information within the JSON line, within the JSON data that we received using the request library. And then for request library, there is also a few ways that you can authenticate. Okay, yes, you are interacting with your REST APIs, but security is must. All right, so it is not just about getting your data or updating your data or deleting the resource, or trying to create new resource or updating it, but it is also about how well are you authenticating your API resources. So basic authentication includes you just typing in your username and password. So auth username and password, this is the basic authentication. So similarly, so response is equal to request.get, you're trying to get the data from this resource. We usually end it here, right? So we just close it here. This is okay when you don't have an authentication to be performed, but when you need an authentication, you have to ensure that you pass in an argument auth, and then you put in your username and your password. And the most common way is you use API keys and tokens, which is provides us more security in comparison to using basic authentication like username and password, because this is very dynamic. API tokens are very dynamic, and these tokens can be periodically interchanged and reversed to make sure that you know your secrets are well managed and maintained by the system. So you use headers, and then within the headers you pass in the bearer tokens, okay, your API token. And then similarly, so response is equal to request.get, you're going to retrieve data from this source, and then within headers you're suggesting the you're getting in your API token keys. Okay, so that's how you use API keys and tokens to access your data from APIs. So our next question: how to schedule recurring jobs in Python. So let's say you need to run a scheduled job. How do you do that in Python? Yes, we do know about Airflow prefix. Okay, but before jumping to that, let's see in a complete Pythonic way. Okay, so you have libraries like schedule or APS scheduler. Okay, also we can use system tools like cron. Okay, so these are the different libraries, all, or you can use your system level tool like a cron job. Okay, talking about the schedule library, the schedule library offers a simple, user friendly way to schedule tasks at fixed intervals or specific time. So it provides a simple and user friendly way, the schedule library. And the AP scheduler, it provides us with more advanced features, which includes scheduling triggers like on what interval, or based on a cron job, or based on the date. And then it also provides us with persistent job stores. Okay, so if you're looking for a simple user friendly library, then schedule library is better. For more advanced features like trigger and then persistent job store, you have to use AP scheduler. Also you can use cron library as I discussed earlier for system level scheduling. And if you're performing it using multiple jobs, let's say you have multiple data flows happening, you need to orchestrate them all together. That is when you use the most common library called Airflow or Prefect, with which you get to orchestrate your workflow. So our next question, how do you convert a pandas data frame to JSON or CSV? This is a very much crucial question, and this is a very basic stuff any data engineer should be aware about. Not only data engineers, if anyone who is handling Python library, you should be aware about it. First of all, I need to import the library. So I'm going to show you a basic example. Okay, the question is about converting a pandas data frame to JSON, but I will also show you how to import and create a data frame. Okay, so first you have to import the library. So you're importing the library called pandas, and you're giving an alias called PD. So instead of typing your library name many times, or it is not going to give you a better readability of your code. So if you use short names, so then it'll be very easy for you to have a better readability of your code, and you can focus more on your logics. So import pandas as PD. Then I'm creating a data frame. Okay, so this is my data. Okay, df, I'm passing it to a data frame object. So pd.data frame is how you create your data frame, okay, in pandas. So in PySpark you have something like create data frame. In pandas you have data frame, and then within that you pass the data. Okay, so name John, Anna, and then age is 28, 24. Okay, so I've created my data frame. Let's see how our data frame looks like. So this is how my data frame looks like. So it is having name and age, John, Anna, 28 and 24. So my question here is, how do you convert a data frame to a JSON or a CSV format? Okay, so now what I'm doing is I'm creating a new object called JSON records. This can be anything. Okay, even if you can just mention JSON data, whatever you want. Then, so this is the key method that you use to JSON. So to create a data frame in pandas, you used pd.data frame. So similarly, to convert a data frame to a JSON, you mention to underscore JSON, and orient is equal to records. So what do I mean by orient is equal to records? So I want the orientation to be in a way that each row of the data is stored as an individual record as a dictionary format. Okay, so each row is going to have a separate dictionary. Okay, the records are going to be stored in a dictionary format. So that's why I say that, okay, orient based on the records. And now let's see when we printed, however, so this was our existing data frame, right? Now you can see that because we have used orient and JSON, you can see that it is a list, but written in a JSON format. So you have a dictionary here, name John, age 28, and then you have a separate dictionary here, the next dictionary, right? So you have name Anna, age 24. So you have list of dictionaries. So whatever the data set that you have, orient will make sure that your data is orientated in a way of creating dictionary within a list. So how do I convert it to CSV? So instead of to JSON, you use to underscore CSV. Okay, and then you are suggesting that let the index be false, so you don't want the index, and let's print it to C. So you are seeing a CSV format here. So name, age, John 28, Anna 24. So this is how your CSV records look like, right? So you are perfectly converted your data frame into CSV format. Our next question is, what is the Parquet format? Why is it preferred? So Parquet is a columnar storage file format that is highly optimized for query performance and data processing. I will show you how the Parquet format looks like. But before that, just know that Parquet stores your data in a columnar format, okay? Thereby ensuring that it is better for query performance, and also it ensures that you're going to have a high or a better data processing. Unlike traditional row-based storage formats like CSV. So CSV is a, how does it store? It is a row-based data. JSON is even more, let's see here. Name is getting repeated twice, age is repeated twice. This is okay for a data with 2 rows, but imagine you have a data with million rows. So you're going to have a repetition of words, therefore increasing your data quantity, right? It's going to increase the storage of it. So JSON is a row based data again. So they store the data in rows, and Parquet stores the data in columns. As I said earlier, yes, we will see how the Parquet format looks like. Just be curious enough. This storage format, okay, but okay, before talking about the benefits, I'll show you how the row based data and columnar based data looks like. So this is our, let's imagine this is our row based storage layout. Okay, you imagine this is a CSV. So your string is the header, integer, and then date. You're having ABC 123, and this is how your data looks, right? So this data, when you take it as a row based data, this is how it gets stored. So you saw this in JSON format as well. So A1, so it's A1 2020-01, B2 2020-02. So you can see that the rows are just placed next to them in a series, right? So this is how your row based layout looks like. So in a row based storage layout, data is stored row by row. So row, first row, second row, third row. This format is simple and easy to understand, making it suitable for smaller datasets or scenarios where the entire row of data is frequently accessed or modified. So this is okay for smaller datasets or where the entire row of data is frequently accessed. Talking about columnar data, the same layout of data, see how does it get stored. So it is storing ABC, the columnar first, then the next column, then the next column. So ABC 1 2 3 2020-01, 2020-02, and 2020-03. So there is a huge difference, right? See here. So if you compare this and if you compare this, there's a difference in how the data has been placed. So in a column based storage layout, data is stored by columns. Yes, we saw that. And this format is ideal for scenarios where analytical queries typically involve accessing only a subset of columns, as it allows for more efficient data retrieval and processing. What do I mean by ideal scenario for analytical queries involving a subset of columns? Let's say I want to access a data from the row based layout. I'm telling where the date is between 0 to 2020 to 03 2020. So instead of just giving me this record, this is going to give me all the row based information, right? So I accessed where date is this, and it is going to information about 2 3 B C everything, right? So it's going to give me all the row information as well. But when I do that using the column based storage layout, and I say that where date is this, so it is going to just give me, it's going to give me the column based data. And because it is column based data, you're avoiding scanning or using all the other datas, the other columnar data as well. So columnar data therefore provides us better analytical performance. Talking about the benefits, it provides us with efficient compression. Because the data is stored in columnar storage, it provides better compression in comparison to the row based storage. This is because data is in column tends to be homogeneous. So you're going to have same variety of data, making it easier to apply compression algorithms effectively. In row-based data, you're having a string type, integer type, date type. String type, integer type, date type. String type, integer type, and date type. But if you see in Parquet, it's all string type, it's all integer type, and it is all date type. So you're going to have better compression ratio because the data is homogeneous. It is optimized for analyticals. Because the data gets stored in column, it helps us with better query performance and therefore giving us a better analytical query performance performance as well. And it involves aggregations or filtering the specific column. As I said earlier, when I need to scan only the date column, so instead of giving me all the rows as well, Parquet just gives us the data from the dates column. Okay, so it also supports schema evaluation. Row based data doesn't support schema evaluation as much as efficient as Parquet. But Parquet, they because these Parquet files they have schema information. So each Parquet file is going to have a schema information. Therefore, it helps us for schema evolution without breaking compatibility with existing data. So you're not going to break your schema evolution or your data flow. Just your schema is going to evolve. So the schema is going to store further information or schema in a further way that it doesn't, stop your schema evolution. And to our last question for the day, what are the best practices for writing clean data pipelines? Make sure that you write the code in a modular way. What do I mean by modular way? So write all your functionalities or your code within the functions. Okay, write all your code. Make sure that this body of code is assigned for each function. What do I mean by function? For example, let's say I'm defining a function to retrieve data. So write a separate code for that. For example, I will name it def get data. So what do I mean by that? Define it using class and functions, right? So get no define your class name. Okay, define your class here. So this is how you define it. So you have your class, and then within each class you define function, right? Let's say I have a function like so this is going to be my one function, and then another function could be like def function update. So these are different functions, and then within this I can write my code, right? Code body. So this is how you have to ensure that you have a modularity or a structure to your code. Therefore your code is very organized, and it gives you better readability as well. So parameterize paths and credentials. What do I mean by that? So instead of hot coding it every time, okay, for example, let's talk about another scenario. Even in our case, okay, let's say I'm trying to access the data, okay. So I'm saying I want to read the data, okay. So instead of defining the file path here every time, because your file path is sometimes going to be very large, right? For example, content slash data slash, you're going to have a lot of complexity. So instead of that, what you can do is you can just define it separately. So file path is equal to, so you just you can define your file path here, and then you can pass it as an argument here, right? So that's how you can pass, you can parameterize your paths and credentials. Same for credentials. So instead of hot coding your credentials, just use parameters, and then use logging and error handling. So whoever is trying to handle your data pipeline, whoever is logging inside, make sure that, or all the loggings from your data pipeline itself, for example an error, It could be a log about how it accessed, when was it accessed. So make sure that you log all these, and also make sure you have error handling in place as well. So if you don't have error handling in place, you're going to have the data pipeline break, right? So make sure that you handle it well. Then before going for production environment, make sure that you test your pipelines locally. Then automate your workflow as well. So it is not advisable, or it is not an industry standard to always go and run your pipeline manually. So make sure you automate it. And then you monitor your pipeline runs and failures. Okay, you might have a failures for different reasons. For example, you might have a schema evolution problem. Let's say your job failed because you didn't set the proper path. Let's say your job failed because you didn't provide the proper credentials. In whatever scenario, it is always advisable to make sure that you monitor your job, check for failures, go for the root cause, try to sort it out, and make sure that your pipeline runs smoothly. So these are the best practices to ensure that you write a proper, or you construct a proper, a clean data pipeline. So that is all for today, and I hope you all learned a lot of stuff today. So make sure that you like the content, and feel free to share it with your friends who are, aspiring to be a Python developer or data engineer, or whatever the field they are trying to get in, but they use the Python language. So make sure that you share this so that they get an access to it. And then do you know click the bell button so that you don't miss on our regular updates. And one good thing about our Data Valley is that we have our channel within multiple domains like Tamil, English, and Telugu as well. So if you're of any based in any local region, feel free to check it out. And we have regular contents coming up daily in different sectors, like ethical hacking, Python, Java, data science, agentic AI, data engineering, Python, SQL, whatnot. Just ask us what you need, and we are here to provide you with all the learning materials for you to get better at what you're doing. Okay, we are here to share the knowledge as an industry expert to make sure that any aspiring individual succeeds in their career. So make sure that you check out all our YouTube channel. And if you would like to join our institute, feel free to check our website, Data Valley, and you're going to have a good information about all the subjects and all the headquarters where we are based in, how we can provide you a better learning, and how we are different to other edutech platforms. Okay, so you will get a broad idea once you're part of it, and we provide you with lot of liberty and freedom to choose depending if we are the best. So we even have refund options. So do check it out. I know it's going to be, if I talk about the Data Valley, it's going to be about all promotional, but I just want to keep this as a Python interview series. So do check our website, and we have our headquarters in USA. We have one more headquarters in United Kingdom, and we have multiple headquarters within Hyderabad as well. Soon we are planning to establish our domains to multiple capitals of our country. Multiple states of our country like Chennai, Delhi, Kolkata. So we are planning, we are growing as possible. And that's why I mentioned we are the fastest growing EdTech company of 2025. So do check out our channel, and hope this video was very helpful to you. So that's it all from me today. And this is Franklin signing off. Have a good evening. Enjoy the rest of the day. Thank you so much. Have a nice day.